whenever we are talking about an update message, right? Update message is one of the type of message that BGP use in order to advertise a route. For example, this R1 is having 10.1.1.0/24 route. This R3 is having, let's say, 11.1.1.0/24 routes. So for example, customer B wants to communicate. So R1 needs to advertise that prefix, right? So when R1 needs to advertise, how it will advertise that? So it will advertise using BGP update message, right? For example, let's say R1 is down for certain reason, right? How the other neighbors will come to know about it, that R1 is down. So in the update message, it will advertise 10.1.1.0/24 when it is alive. This is what referred to as feasible routes. And along with this route, basically, or along with this NLRI, it advertised the path attributes. Okay. So update message is a package that it advertised the prefix for the reachability in terms of B. Without update, customer B cannot reach, right? Whenever it is down, then what it will do, it will withdraw. It will withdraw the prefix or withdraw the subnet. And how this withdraw message has been carried, informed by others, same by update message. So update message is nothing but a message type of BGP which will advertise prefixes, feasible routes. Also, it will advertise the unfeasible routes. The difference between that feasible routes will be, it will carry the attributes by BGP update message, and simultaneously this BGP update message will advertise those, right? And one important thing to understand also is, so when R1 advertise that to R2, so R2 will consume this, receives this and consume it inside the memory and regenerate a update message for when it advertise. It regenerate, and while advertising in the eBGP neighbor, basically it will add the AS path to that particular NLRI while advertising it. When R1 will advertise to R2, basically this is iBGP neighbor within the autonomous system. So the AS path in this update message for this NLRI will be null. While R2 advertise that to 65002, R2 will add it while advertising. So update message is not end-to-end, regenerate every hops whenever it advertised. And then required attributes, path attributes will be added or removed. This is point number one to understand. Point number two is, think about R2 is advertising to somewhere this device. Once R2 advertise, what will happen when it receives? What will happen when that update message is received? How that is been update message is been processed. Very important step to know about how update message has been processed. Let's say R1 is in AS100, R2 is AS200, R3 is AS300, all are eBGP neighbors. So when R1 advertise a prefix, let's say prefix is 10.1.1.0/24, it advertise. So once while advertising, it will have a next hop. Let's say next hop is 1.1.1.2/, and then we will have an AS path. AS path is 100, and then it advertise to R2. So first and foremost thing, whenever a route is being received, the route is being received in the input queue in the device. After that input it receives, first thing it will do a AS path validation. Whether in the route, the AS path, my AS path is listed in this. For example, if this route is listed, then it will drop. It will look at it. It will check, okay, this is my AS path. My AS path is 200. Configured AS path is 200. So I will drop it. So AS path validation is done first, very first after the input queue. After that, any kind of inbound policy has been there. For example, a route has been received in my gateway, and then I want to add like local preference. I want to add AS prepend. These things, for example, many other things are also be there. So it will check for any kind of inbound policies is been there or not, and then apply those inbound policy. After inbound policy, basically what it will do, it will store that route in ribbon table. So in ribbon, for example, in ribbon table, basically this 10.1.1.0/24 prefix learned from, let's say, R1. Also, it is learned from 0/24, learned from R4 as well, right? So if a destination learn from two different neighbors, then what we need to do? We need to select one as a best path, right? So for that, we need to perform a best path algorithm for a prefix received from two neighbors, same prefix received from two neighbors. So based on the BGP best path selection criteria, it will only select one best path and it will only advertise one best path to the neighbor as well. Okay, so basically it will select one best path and then it will install that best path in rib local for further forwarding in order to forward or in order to advertise, right? So install that in your routing table as an active path. Once it installed in the routing table, any kind for while advertising that, it will basically check any kind of outbound policies are there. So outbound policies are what? So for example, R2 advertising to R3 and I want to influence this route. So I will add med, right? So while advertising that, basically we do a outbound policy to add a med and other things as well. So apply outbound policy and then it will basically advertise. Then it will advertise the routes. So whenever a route is coming from R1 to R2, it will put in the input queue. Based on this input queue, it will do a AS path validation. Based on this AS path validation, it will check any kind of inbound policies are there or not. After inbound policies, it will store in ribbon table, do a best path algorithm. And based on this best path algorithm, it will put in the rib local table. Based on rib local, it will do it will see whether any kind of outbound policies is there and then advertise to R3. Every router, whenever it receives a route from its neighbor, it will do the same thing. AS path validation is being done for all the eBGP neighbors. For iBGP, AS path do not matters, right? So AS path validation is required in order to avoid loops. So basically, in order to understand how the AS path validation happens, you can check my loop prevention video. Okay, so this is how basically a route has been advertised, a route has been received, and then how that route is installed in the routing table and then advertised. So basically, another important thing is, remember, route stored in ribbon table. These are might be many next hops, many neighbors are advertising this. Route best paths are stored in rib local table, which is your rib, or you can say routing table, and we will have rib out for advertising a prefix. So while in order to receive that in the rib itself, basically it has to pass till this, at least AS origin validation and inbound policy, and then it will store in rib. So you can see that what routes that you receive in ribbon. So these steps is important when you are doing any kind of troubleshooting. So for instance, we saw that how we update our NLRI to the neighbors, right? And based on, for example, as per our example, 10.1.1.0/24 is there, and then we advertise that using BGP Update Message along with the path attributes and all. For instance, this router crashed. So now R2 responsibility is to send an update message to 65002 stating that we are sending a withdraw message, right? So R2 will advertise, R3 will also advertise. R65002 autonomous system also advertise, inform 65004. 65003 will also advertise and inform 65004. 65004 receives two update message, so it will update, send it to directly to, as it's receiving from two different autonomous system, so it will, two of them will send it to 65005. This is a normal case that a withdraw message happens. So when, for example, this is not the optimized way to do that, so basically we will have like MRAI. So what is MRI is minimum route advertisement interval. It's like an SPF delay timer. So SPF delay timer is basically, or MRI is wait for the update message before it do a calculation, SPF calculation, or right. Similarly, for example, at T1 it advertise, at T0, so what will happen is T0 this is down. At T1 R2 advertise to 65002. At T2 at same time T1 65003 advertise. At T2 basically 65002 advertise to 65004. T3 65004 advertise. So both of these update message in general it will be sent to 65005. But if we have MRI configured or it's been there in the devices, right? So what will happen is it will wait for that MRI time before it get expired. So at T2 it receives, it will wait. If the timer is not expired or within that I receive T3, then it will advertise only one to 65005, only one withdraw message to these customer B. And this withdraw message is nothing but an explicit withdraw message, right? This is what referred to as an explicit withdraw, that it removes the route from everywhere. Okay. So what happens, for example, in terms of this is a route has been advertised, and based on this route advertisement, so this is the best path for customer B to reach customer A. And in between what happened is this path is down. So once this path is down, so we already sent an update message. So we already sent an update message to R3 to 65003, 65003 to 65004. 65004 did a best path algorithm and found this green path, right? Now what happened is 65002 link is down, so it will send an withdraw message. Once it sends an withdraw message, what will happen is 65004 will remove this path, okay, and add this path, best path to reach, and then what will happen, it will advertise that new path information to 65005, right? So 65005 receives a new path, now update that, and now the best path is from this. So what happened here is basically with an implicit withdraw message, it simply advertise a new best path, right? And based on the new best path, it will remove the older one and put the new best path to it, right? So, but in case of explicit withdraw, what was happening was it was sending the actual withdraw message for a given prefix to all the devices. But in case of implicit, what we are doing is implicit withdraw is sending the same prefix with a new attribute, which will replace the old path with new one, and then the traffic flow will resume. There's a difference between an implicit withdraw and an explicit withdraw, right? So what we discuss in this, what we conclude with this is an update message, BGP update message carry NLRI information. It will update whenever a new prefix has been added. For example, 192.168 1.0/24 has been wants to add, so it will advertise. Based on this advertisement, while receiving that, it will process in the input queue. It will check based on what kind of AS path validation, then inbound policy, ribbon table, best path calculation, and it will put it in the rib local table. Rib local table is there, what is there in your routing table for use for forwarding. And after that, basically it will do a outbound policy check and then advertise to the neighbor. An update message also update a feasible route like this and an unfeasible route when it is down in terms of withdraw message. Update message will carry your attributes for a feasible route, but update message when it's a withdraw message will only the prefixes that we are advertising. Withdraw messages basically explicit and implicit. Explicit used to withdraw the given prefix. Implicit is updating a new path that will replace the old path, for traffic forwarding. So this is what an update message also carry a withdraw feasible and unfeasible route, multiple feasible and unfeasible routes together to advertise. Hope this is clear.